Okay, so house robber 2. Let's see what's the difference between this one and house robber 1. We just did. Okay, all the houses are arranged in a circle, right? Okay, first house is the neighbor of the last one. Okay, that's the difference. First house and the last house, we cannot pick both. We have to pick, if we pick one, then we cannot pick the other one. Right. The rest of the setup seem to be the same though. Two adjacent houses are working the same. Yeah, okay. So we can probably do the same thing. We can do just, okay, we can pick one, and then the pick method will just have this and have the starting index, right? And then, so if the starting index, right, so okay, starting index is greater or equals to the limit, then just return 0 because there's nothing to rob. And okay, this is like I less than plus, very similar to house robber 1. Right. So we're gonna have the max in here, and for each of the possible choices, we define a money equals to num size. So if we pick that, if we pick the, okay, sorry, it cannot be 0, but from the start, if we pick I, then we cannot pick the adjacent ones. We have to do I plus 2. Okay, yeah. And we money plus equals to that. So if max is less than money, then max is equals to money. When we return that, we return max, right? This is this. But the difference is it's a circle, so we can't, there's something wrong with here, probably greater than. Okay, so if we're picking the first one, then we have to have a less limit. If we pick this one, we can have a further limit. So we're gonna pass an n in here, and if it's greater than end, return 0. Okay. So what is the end value? Right. This is going to be two choices. One is starting from 0, which means pick the first one, but then the last one cannot be picked. The end will be minus 2. Okay. Max of pick. And this is pick nums starting from 1, and then this is good, I think. So I have a better end. I have a the normal ending. Greater than. Okay, I think this works right. Let's see. Great, but it's the same thing, right? We have a lot of repeated calculations. We will want cache. Cache for what? Let's do a map. Integer, cache. So we have a map. Cache. Okay. So otherwise, if it's not reached the limit, then we gonna first check the cache. Start. Right. Yeah. So if it does have that, then we just immediately return get start. Okay. This is fine. This is okay. So before we return max, we're gonna cache it first. Start max. Okay, this is good. Now we'll pass the cache. Maybe I can just do this. The cache here. And cache here. And then you pass the cache here. No problem. Cache. Yeah, I think it should work. Okay, let's try that. It's not working. So 1 output 0. That's weird. If it's okay, 1. Oh, it's a special case, right? Because of this. Now it's the 1. The first one is the same. It's a special case. It should pass. Otherwise, like if there are 2, then none is 2. Yeah, I think they should work now. Okay. What? Why this doesn't pass? Yeah, I was not able to figure out yesterday. So, but I was thinking along this problem as well. So I noticed that in here we're actually having a 4. This is because we are using this 2 and then this 2 as well. So what? Like the reason for that is being we passed the n index, but then we did not actually use it in here when we're iterating through all the indexes. So which means it still goes past and beyond the n index, but go to the length of the array. So we should change this to be guarded by this index. So after this change, this should be pass fine. Yeah, and I also submitted just now. It passes all the test cases. Yeah, it's like took me a while to figure this out, but yeah, oh well.